All right. So question number 7 might look like it might give you kind of flashbacks to question number 4, but it's a little bit different. All right. So if I took this limit as n approaches infinity of n plus -1 to the n over n, right, we might say, oh, it diverges, right, for the same reason that this -1 to the n is going to fluctuate between positive and negatives. However, we can rewrite this as n over n plus -1 over n to the nth power. So this is like taking the limit as n approaches infinity. N over n is 1. -1 to the n over n. Well, what do we know about this thing? All right, so I know that -1 to the nth power is always going to be strictly greater than -1 to the n. Actually, let me do this one. All right, so -1 to the n is always going to be at least -1, but also less than or equal to 1 for any value of n, right? It's going to fluctuate between -1 and n, or negative n and n. I can divide each of these by n, and then I can take the limit as n approaches infinity, right? So if I take the limit of these things, we got a squeeze theorem. It all ties together in this class. It's like someone thought out this math thing, not me. I'm just doing my thing over here. So if I take the limit of -1 over n, we know that this is 0. The limit as n approaches infinity of 1 over n is also 0. So this thing in the middle also must be 0 by the squeeze theorem. Right, so this limit is going to end up being 1 plus 0 or 1. So this thing also converges. So this -1 to the n is getting smaller and smaller and smaller, right? If you were to graph this thing out, right, you're going to have things that look like, say, this big boom, but less and less and less as time goes on, right? So those right, so it's going to kind of converge around to 0. Looks like a zipper. It's late. It's very late.